Hi, Philipp. Thank you for being here. I would love you to introduce yourself. What are you doing? Where are you working? And a short introduction. Afterwards, just for the audience, afterwards, I will start the recording. The sessions, the talks are recorded. So we will play the recording. But afterwards, there's a Q&A session. So if you have questions during the talk or after the talk, stay in here. You can ask. Philipp will be here and will also answer them normally within the chat also. The most important ones, who are the most interesting ones, which we think are interesting, will we pick up and ask later anyways, so that people who are not part of the conference and watching the video later can also enjoy our great discussions and topics we are talking about. Okay, Philipp, please introduce yourself.
Well, hi, I'm Philipp. I'm also based in Austria, though I am in Vienna. So this is like the Austrian session now, I guess. So I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. Just in case people are confused, no, Elastic doesn't have an office in Vienna. We work from home, like always, not just now, but before as well. And we have a couple of people in Austria and many more in Germany, but no offices. I am generally a developer advocate, so I mostly travel around and speak at conferences, but not right now. Because the travel life has kind of changed a bit, which is kind of sad, but also kind of opens up new opportunities like more virtual events. And this one tries to have a bit more of a creative approach around different channels and meeting people, which is interesting and nice. Yeah, my session is, I think, pretty much exactly 30 minutes. So that should fit in nicely into the time slot. And then we can have some questions, and I'll also keep an eye on the chat in parallel. So let's dive into logging. Probably you have lots of logs and you want to collect all of them to get a better overview of what is happening. And for a long time, you often tell yourself, well, this is fine and this is working the way I expect it to work. But then you look at the details and oftentimes it's not as fine as you might think at first. Either you have these huge log files and then you try to grab through them and you're the little submarine that doesn't find anything. Or you have lots of servers and you don't know where you SSH to anymore anyway. Or you have so many containers that just appear and disappear that you have a very hard time keeping track of everything that is going on. So we want to find a better solution for that. And what we don't want to have is we don't want to have everything is on fire, which, well, is kind of a well-known comic. So we need a better solution. One of the many better solutions that are out there and that is very widely used and popular is the ELK stack, which stands for Elasticsearch, Logstash, and Kibana. Elasticsearch stores your data, Logstash gets and parses it. So for example, if you have a log line, it could extract the log level and maybe the server or service. And then Kibana can visualize what is going on. And that has been around for quite a few years by now. The one thing that happens when you have been around for a long time is that new best practices appear, and then you need to fight kind of like the old best practices because people are very used to the old way. And this talk is both introducing a bit the old way, but also tries to push a bit more to the new way and how to make your own life a bit easier. So this is what I want to get to here. And for that, we have another new component called Beats. And then we try to rename ELK to something called BELK or ELKB. So you can see the ELK is evolving and might end up like this, the BELK or ELKB. The problem here is every time we get a new component into our stack, we would need to redo the branding because we get a new letter. And then it's getting very hard to make up new animals all the time. So by now we try to stick to the name Elastic Stack because in terms of naming, it's very scalable, like the rest of the system. But if you still say ELK or BELK, we will understand. But we try to just call it Elastic Stack. So if we add, for example, tracing today, we don't have to add a T for tracing or APA for A for APM to the stack. and we don't need to make up new animals. So what you might have in your stack is then beats as a lightweight agent or shipper. This is written in Go, so you have native binaries, and it's just forwarding. It's a bit like tailf, but over the network and on steroids. At least that's the case for log files. There are other beats except or besides file beat, like metric beat, packet beat, audit beat. They can do different things. They can collect different pieces of information, but for log files, you will mostly stick to log files, so file beat. And you can either forward to logstash then, which can parse and enrich and is kind of a very versatile tool, but it's also a bit heavy. Or instead, you could directly forward to Elasticsearch, which can also do some things that Logstash can do. Store the information here and then visualize in Kibana what is going on. So this is kind of where we are at. Side note, I'm just showing you a Hello World application today. Your real applications will be much more complex than what I'm showing you, but this is just a starting point to put you on the right track. So let's dive into that. I will stick to Java and I will use SLF4j as the logging facade, Logback as the logging backend, and then I will also add MDC, the map diagnostic context, so that we have some more structured information. And for that, we will then add a bit later on 2 more potential libraries, though I will only focus on the first one. We have our own Java ECS logging library, and ECS stands for Elastic Common Schema, which is basically the way we name things, which brings a lot of semantic meaning to Kibana then, for example, and also makes it easy to correlate data. If you want to have more control and want to kind of influence how things are named and have a bit more power yourself, there's the logstash logback encoder, where you have more freedom. It has more overhead, but it allows you to do more things. Alternatively, if you use, for example, log4j2, there is a logstash layout for that one that allows you the same things, but I will stick to logback for today. So if you're in any other programming language and people tend to make fun of PHP, for example, but even PHP has a proper logging backend called Monolog. And in most other languages, you have something similar where you have some kind of structured logging and then logging backend where you can plug in how you process or what you do with the information that you have collected. 2 things that we don't want to have in our logging. Obviously, the first thing is you don't want to use system out because you want to have proper log levels, but you also want to have the possibility to configure different logging backends. And we'll dive into multiple options there. The other thing that you don't want to have is too much coupling. So your application shouldn't need to know too much about the logging backend where you log to. So this is another thing that you try to avoid. And we'll kind of revisit that every now and then. So let's start with the good old approach, and that is called parsing. What parsing does is you take a log line, you break it into individual pieces, and then, well, you start searching in those. So I have prepared, like in any good cooking show, and I hope that Knife tries to simulate that already. I have written a very simple Java application that logs. So we have a loop here from 1 to 20 inclusive. We generate a random session and then we have a loop counter. So these we add as structured information here. If you, for example, had users that log into your system, that might be the user ID that you add here. So if a user later on complains and says like something is broken, you could just look up what happened to that specific user. Here, I don't have users. I keep it super simple. This is really just a hello world. That's why I have these 2 like placeholders for structured information, for example. And then we have a trace statement for every run. And then we implement this pattern here. If something can be divided by 15, we have a runtime exception. If something can be divided by 5 and warn, by 3 and info, and otherwise a debug message. First, what is the pattern here? Anybody who has recently done any job interviews probably knows what this is. This is FizzBuzz. The other thing is, how many log messages should we have? So we have a loop of 20 inclusive. Then we will have 20 trace statements and 1 for each loop iteration of these here. So 40 messages in total. This is what we should have. And we'll see if we always get that many. What we then get, for example, if I find here my log lines, this is, well, a classic log line that you can see here. We have a timestamp, we have a log level, we have where it was coming from, the method, we have that session and loop, and then we have the log message. Iteration 1, session 72. Easy. Let me make that slightly larger so everybody can read that. I hope this is large enough for everybody. So this should be easy to work with, right? So if you do the parsing approach, how do you do that? What you need to do is, and let me head to the slide so I can actually show you the structure. You write your log file, then you have file beat, which basically tails the log file, forwards it to log stash, which will do the parsing. So it takes that log line that we have seen and breaks it apart. And then we store the broken up pieces in Elasticsearch and visualize them in Kibana. How do you break something apart? Normally with a regular expression. And yeah, I assume some of you already think, well, this sounds like a lot of work. And it kind of is. I try to avoid it if I can, but sometimes you cannot, because regular expressions are tricky to write and even trickier to read. When I ask who likes writing regular expressions, a few people will always raise their hand. And I would normally say that, well, this is kind of the Stockholm syndrome. You get so used to writing regular expressions that at some point you decide this is the right way to do things. And I don't fully agree that this is really the right way to do things. Or it might be job security, because while you can write your regular expressions, few other people will be able to actually read those. So maybe it's just job security as well. But this is the pattern that we have used here. And I will link to the code at the end since we only have half an hour. I don't want to spend too much on that, but let me give you a brief idea of what we do here. So I have, this is my file bit that will send to Logstash. It basically picks up some configuration where I have defined the path with the log file, that it will take that, it will forward that to Logstash, and that will break that apart then. And we can look at the Logstash configuration. So this has the input from beats here. And then this here is the regular expression. We call the regular expression in our stack grok. It's a named regular expression. So basically you have this here timestamp is how the timestamp looks like that we had in our log. So this would be the right regular expression to parse the timestamp. And with this entire pattern, we basically say, take that timestamp and put it in a field called add timestamp. Then there's a space. Then there is a log level, put that into a field called log.level, and so forth. So this is how you write regular expressions. If that is a lot of fun, could be debated. We have some tools in our stack in Kibana now to make this a bit easier. So you could paste a log line and then try to write the rule to actually break that up and see, like in an iterative fashion, how it works out. But it's still a bit tricky to get right. So this is the right regular expression since I've written it already, but you might not want to do that. Now let's head over to Kibana and see how many log messages we have. By the way, I have started my application once and then run it a second time. So how many log messages do we expect in total? Probably 40 plus 40 should be 80. When I look at this here and I head over to my parse index because that's the one we want, this will give me a number, but probably not the right number. So now you can see suddenly we have 82 messages. We had 42 here and 40 here. I ran this twice. In the first one, I had a bit of a bug or error that I corrected, and now the second one is correct and only shows 40. Just to show you the result, what we have in here. So we have, these are all the different fields that we have extracted. And for example, we have the log level. I've mentioned that before. And I could just extract that by toggling that column. and I toggle that column. And now all the log entries just show this log level. Let's scroll through them and see what the mistake was that I made in my first example. So here you can see we have lots of info warn, debug, whatever, all the levels that we had over time. And as I come down here, you can see here we have one that doesn't have a log level. So this already looks slightly suspicious. When I open this one up here, let's see what we have. So here you see message Java runtime exception bad runtime, and it also says grok pass failure. By the way, if you write regular expressions, you can just search for those, and then you see any lines that don't match your parsing rules. What might have happened here? So in my application, I had somewhere in here, I had a stack trace. So you can see this one here. This is a multi-line log message. So we have the actual message, and then we have here 2 lines in the stack trace. And this is a very common problem, that you start breaking up stack traces into individual lines, because by default, FileBit will consume 1 line and assume that this is a log message. How much sense does 1 line of a log message make? Not much. So what you need to do is, and I have already done this for the second example, in the FileBit for logstash configuration, where I have collected this log file, I have, for the second run, I have enabled this multi-line pattern, which basically says, if the line does not start with a square bracket, like all the other log messages, then it's a continuation of a previous line. So if something starts with a square bracket, it's a new log entry. If it doesn't, like those 2 here in my stack trace, they should be combined with the previous line, so we don't break up the stack trace. So this is what has happened in the second run here, where I have already corrected this. So this is why this one has 40, this one had 42, the 2 extra ones were basically the 2 lines of a stack trace, which didn't make any sense. These are just some of the problems that you might run into, like multi-line statements are problematic, but also your application, and let me skip to like the kind of like discussion of this part. Multi-line statements are a problem. If you change your format, you need to change your regular expression. And of course, you need to write your regular expression, which is kind of stupid because your application already knows what is what. Then you write it out to a line and then you need to parse it back. The good thing about this approach in general, though, is you don't need to change your application because it's just like how you used to write and consume logs. How could you do this differently to make this smarter? So one way to do this might be to send logs directly. So rather than writing to a file, your log appender could send directly to logstash. You don't have to do any parsing because there is no file to parse in between. So this would look something like this. Your log appender knows where logstash lives, sends the log message, and that just has everything in the right way, and then can just store that directly in Elasticsearch. What you need to do in logback basically is you need to say like, okay, this log appender will talk to logstash, and then you just need to know where does it live, and then it will just send everything encoded the right way. What is the downside here? We mentioned coupling. In the previous example was like if you change the log output, you would need to change the regular expression. Here it's kind of worse because here suddenly your application needs to know what is the logstash instance or what logstash instances do you have where I can send my logs. So you have more coupling. Also, when I look at the practical example here, let me switch to the send index. What you have in the send index is how many log messages do you expect? Ideally 80, I guess. 40 plus 40. But we only have 40. And this shows another problem that you have with this approach. So what happens if your application runs and the logstash instance is down? And then your Java application is already shut down before it could reach a logstash instance. And this is a containerized setup. And my Java application just starts and stops before logstash could even start up. That's why on the first iteration, when logstash was not running yet, the log messages didn't go anywhere. And especially when the network is down or having problems, you kind of want to see what is happening in the logs. So that's when you're interested in what is in there. So this is kind of, besides the coupling, the error handling is kind of problematic in this approach. So yeah, the good thing is you don't have any files that you would need to parse, but outages and coupling are definitely a downside of this approach. So what else could you do? The choice that we would recommend in general is to structure your logs. And since Elasticsearch stores JSON internally, we would ideally output data to JSON directly, because then Filebeat could just collect the JSON, store the JSON directly in Elasticsearch, and you're done. So what this looks like is your JSON file is being tailed by Filebeat, put into Elasticsearch, and we're all done. So what that looks like is, first off, let me show you the logback configuration for this one here, because this might seem a bit trickier. This is just a regular configuration for a log file. So I call it whatever log file -ECS, because that's the naming convention that I use in here, and it's JSON. It just uses a rolling file appender. So it will be rotated and will keep a history of 7 files. What is the relevant thing about the ECS logging appender that we are using here is that it just uses the ECS encoder. I call the service logme, and this is all I need to specify here. And this will then produce this ECS JSON file that is just in the right format and follows the naming convention of how Elasticsearch expects fields to be named. So here you can see we have a timestamp field, we have a log level, we have the message, we have the service name logme, which might be helpful if you want to filter down because you have many services. You also have here the MDC information, so session and loop. The MDC parameters are kept the right way. So you didn't need to specify any mappings or any fields or anything. This was just done automatically for you. Now, if I head over to Kibana, how many log messages do we expect in this one? And this is the structure index. This one should indeed have 80 because there were no errors. It just parsed everything correctly. And you can see, okay, we indeed have 40 and 40. So this looks good. You can see the log level. Those are all filled. And we could just look at the structure of this one. But for a change, let me show you the JSON just so you see what we have actually collected here. So we add a bit of metadata around it. So you can see the index where this is stored. You can see, for example, this is the source information. So here we have the service name, the session, the timestamp, etc. We also add, for example, the agent. So Filebeat, unless you remove it, would say like, okay, this was the Filebeat version that has collected this log event. You know where it's coming from, etc. You see the ECS version that this is complying to. This is then coming from the ECS logger. You see the log level. So all the relevant pieces are here that you can work with that easily. Yet you didn't have to do any or much manual work. Just in the log appender, you had to add the right logback appender to spit out the JSON, and then Filebeat can just tail that file directly. And that's it. So this is simple and kind of the recommended way to do it. Oh yeah, I can show you the configuration here. So to collect that with JSON, you would just say like, okay, whatever JSON file we have here, and then it would say, yes, we have the keys directly under the root. If we have any duplicate keys, just overwrite them. And if there are any errors in collecting the JSON, just write those out. So this is kind of a good Filebeat configuration to collect the JSON that has been generated by your ECS logger. The good thing is this is the right format. It might have a slight JSON serialization overhead, and sometimes people say like they don't like reading that format that much, but it generally just works very well and is what we would recommend. It doesn't have much coupling. Your application and your logging backend are very separate, and it doesn't have, it doesn't need much manual intervention. So this is a nice approach. What happens if you containerize your applications? And I assume that you're using Docker here. So where do you log in the first place? probably to standard out, because yes, you could write to a file, but then you would always need to mount files around and collect the right files. And if new containers appear or then disappear, you would always need to make sure that you mount the right files and move them around and collect them. If you write to standard out, you can then just collect the JSON file that is by default being generated by Docker, collect that, and you're good to go. So that is the console output in your logback. One thing that you should not do here, by the way, is if you add highlighting, that will show up as extra characters, because what is highlighting on the console is if you just interpret all the characters, just kind of like some garbage characters. So don't do that. Just remove any highlighting and just include kind of like the regular pieces of your login. Where do you put your file bin in that case? In a sidecar. So you have one file bit running that will then just tail all the log files being generated by JSON, and you're pretty much done. I can quickly show you the configuration file for this one here. So here I have file bit for Docker, and all I do is I just say like file bit auto discover and use the Docker log file here, which by the way implies that into the sidecar you have mounted that default log location into the sidecar, because it kind of like relies on this default location to pick up the right files. So this is also a good approach, and then just does the right thing. There are a couple of other ins and outs, but I don't want to go too deep into them here. General architecture looks very similar. So we have all the log files. The sidecar just tails them and forwards them to Elasticsearch. If you want to have like some configs of how to deploy this in a sane way, we provide them as parts of the Beats repository. It's just in deploy Docker. There you can get all of those config options. What is kind of nice is that you can add hints. So if I have a label fizzbuzz in my application, I could just find that. Or if you have multi-line statements in your logs, this would be the pattern. You've seen this pattern before. This is how we could tell or put these labels on the image. And then when FileBit runs into an image with these labels, it will automatically know which rules to apply. So rather than configuring explicitly apply these rules for this image, what you do here is you bake the rules into the labels of the image so that FileBit will pick them up automatically. So it's a bit of an inversion of control who says what should happen. If I look at the Docker logs, how many logs will I have in here? Many. Because I didn't specify from which container I want to collect logs here. This was just getting logs from all the containers that I had running. And when I ran this initially, it had multiple file beats and it had Logstash running and it had my Java application. And so there was a lot of activity. So there will be, not just 80, but 1,000 something messages. What you can do then is you can just filter down here. And I could, for example, say Docker container labels app. This sounds promising, equals. And then we have this fizzbuzz label that I've shown you before. If I search on that, then again, you should only get the logs from the containers with that label. So just the Java application. So this one here should give you 80. Why it has 81, don't be confused. There is one initial message when the logger starts up. This is the very first message that we have. That's why this one has 81. But otherwise, this one is doing the right thing and getting the right log levels and everything. So here you can see it has some extra metadata fields here. But if I stick to the JSON view of this, the JSON view will then be able to show you, or just shows you the right values. Go on here. And here you can see, this is, for example, the Docker metadata that we have collected that the FileBit could also use. You can see the agent that has collected the information. And further down here, you can see this is again the right information that we have extracted from this one. So this has the session and the package and the offset at the log level and whatever you had in there. So this will make your life a lot easier to work with here. This is nice, and it's kind of like the hot stuff that everybody wants to use. It's just a bit more complex in how to get to the logs and how to process them. If you want to walk through the entire example, 30 minutes are not enough, but I'm sharing the repository at the end, and there you can see all the different steps how to get that going. Finally, if you want to use any orchestration, I assume you're using Kubernetes. And with Kubernetes, it's kind of like the same thing. You still log the system out. Now you have a daemon set, so this is one pod running on every host for Filebeat to collect all the log files and will then forward it. Otherwise, it's relatively similar to what Docker does. If you want to get all the YAML to configure this, this is the repository in the Beats repository where you can find that. And this would be the right configuration, how to actually say, rather than saying Docker, now we have type Kubernetes. And again, you can use these hints, the labels on the image to actually pick up metadata. And you could then just say like, this is where those logs are coming from. Has a couple of other pieces which are not that relevant. It's even hotter, but it's even more complex. So these are kind of the downsides here. So to wrap up, if you want to run this, go to this repository, clone it, run a Docker Compose up. It will automatically build the Java application for you. It will start all the Docker containers locally, so it might take a while until you have downloaded everything. Give it a couple of minutes to actually do its work, and then you can see everything in the Kibana dashboard that I have shown you here as well. And you can just play around and see how all the bits and pieces are tied together. It's probably easier if you kind of like play through it yourself with the code rather than I try to explain and walk you through it here step by step. We've looked at parsing as the classic approach if you have to, because of regular expressions. Sending if you must. It's kind of like you don't have to parse, but then what happens if there is an outage and you have more coupling? Structure if you can, that is the recommended approach that we would give you. So log out to JSON and then just tail the JSON into Elasticsearch. If you have containers, Filebeat as the sidecar and just collect whatever has been logged to system out. For orchestration with Kubernetes, run as a daemon set and again, collect everything that has been logged to system out and you should be good. If you have any questions, find me now somewhere at the conference virtually, and I'm happy to answer. I hope you have learned something. Thanks for joining.
Thank you, Philipp, for this nice introduction into logging. It was quite interesting for me as a logging noob, basically, who always complains about that Kibana is too much information overall, but we are not responsible for the logging, so I can talk about that. Yeah, I find it very interesting. There are already some questions in the chat. So Roman asked, what do you think about the Kafka in front of Logstash?
Yes, maybe. The answer is always it depends. Maybe Kafka may be read as like any message queue. Like the general idea why you might want to have a message queue is you have something that is very spiky, and maybe your system will not be able to kind of like capture that peak load or peak generation of log events. That's where a queue will make a lot of sense. Obviously, the queue will not help you to have like higher ingestion rate than you can do on average, but it's mostly to kind of like capture spikes. Sometimes it also makes your architecture a bit simpler because you just have Kafka as a connector between everything, and then you don't care about it anymore. So that's definitely possible for that as well. If you don't already have a queue in there, you might not need it. Logstash has persistent queues, so they are stored on disk as well. For that. So if you don't have a queue at all yet, maybe you don't need to introduce one for that. But it is a common feature, especially for very large setups, that there is some queue, mostly Kafka, to be honest, in the mix there. mostly to keep your architecture simpler and for spiky logging patterns, basically. That's where this comes into play.
Okay, thank you. I hope, Roman, you are satisfied with that answer. There's also a second question from Carsten. What filters do you support on Kubernetes to restrict the pods from which logs are acquired with FileBeat? Can this be changed dynamically without restarting FileBeat?
So what you do is, I briefly mentioned this, that you can have like the auto discovery with the labels on the container or pod. And what you can do is either you collect everything by default, or you could even have a rule where you say, don't collect any logs unless there is a specific label on that pod. So for example, you could add a label log me or FileBeat or whatever, and only then would we take the logs from that specific pod. So that is one of the simpler mechanisms. You could also make this explicit, like you could just have an explicit rule and say like, if it's an Nginx container, then I want to fetch the logs or not, or want to mutate them, whatever. So you can make this either more like annotation based, like you annotate the container and then either you have like collect everything by default, or you only collect what is kind of like on the specific list. Or you could make explicit rules like if these two labels are present, or if the version is this and that, or if the base image is something, or anything that is in the metadata you could use for that filtering. So you can make it relatively complex. If that is always advisable, I'm not sure. What might be interesting is, for example, that you could use different retention times or like storage mechanisms based on the namespace, for example. Or maybe you could even have like annotations in there, like how long you want to store something. That is not really Kubernetes specific, but for example, one thing that I've seen sometimes was that people say like something is security related, then we want to store it for like a year, and something is just like the operational logs, then we only care for 2 weeks for that. And we basically store them in different places, so we can have these different retentions and make different rules. So you can tie into all the Kubernetes metadata to work with that. But it just plays like anything else, that as long as you have something to differentiate what is what, you have kind of a lot of flexibility of where to forward it and how to process the data then.
Okay, I'm not really deep into the topic, so I'm not sure if the second question from him is then also answered. What if I add the labels during runtime?
Which labels? So I'm talking about the labels on the container when you create the container image. You mean if we change anything at runtime? I think that should still be picked up. Like even so, the way I set up my rules, even like they will be reloaded every 10 minutes or whatever. So I think that should be doable. So I've never seen the use case where somebody tried to apply a label and then change the logging in the middle of a running application. So what I normally see is that people build a container in a specific way and then apply like those rules on that. But you could, of course, then filter out stuff later on as you refresh rules.
Okay. Carsten, please, if you have more questions regarding that, or if you do not think that was sufficiently answered, please ask more questions. There are also two more questions, one from Thomas. By using Kubernetes or Docker and Beat, the log lines written to standard out contain structure only for container metadata. But how can the logged line by application itself be structured in such an environment like log level or component?
Yes. Since we only had 30 minutes, I kind of glossed over that. If you look at the code that is running behind there, and maybe you saw in my last example with containers, I was still extracting the log level and everything from the log messages. So there are basically two ways you can have that. So first off, you have the structured Docker log from system out. And then you can either parse a log line within that, like the log message itself, you would still need to parse. Or if you have JSON in JSON, then you could just decode that other JSON in there. Like you have the JSON log message from your application, and that is embedded in the JSON metadata from, or the JSON metadata from the system out log. So you could use those. So you can still get like the extracted values out of the log messages from system out again. Either parsing it if it's not structured, or decoding it with the JSON decoder. For example, if you tell like there's a message field, decode that as JSON because I know there is JSON in that field. And then you don't have to do the parsing anymore. And that's how you would get the structure inside the Docker or Kubernetes logs.
Okay, thank you. Roman also asked what your experience is with APMs. Let's say there's a Java app which is quite complicated. Is it getting interesting right away, or do you have to adapt the application somehow to get useful output normally?
I think there is like, that's a good point. Like the way I would see it is that logs are manual and they're at the component level. Whereas where tracing or APM comes into play is like at the entire system level. So you see the entire call as it happens throughout, like one service calling another. So it's not just on the component level, but it's really cross-cutting against one or multiple calls in the system. So it's kind of similar things, but it's like different views. So for a log, you really care about like, I make this statement at this point and I explicitly state that. Whereas what tracing and APM does, it follows the entire call and then sees like a more cross-cutting concern from that. And depending on what kind of error or problem you're trying to fix, tracing can be very efficient. Also because oftentimes you don't have to explicitly annotate anything or like say like log this or trace this. Because where the value of tracing or APM normally comes from is that it understands like frameworks, like, I don't know, you're using Spring Boot or whatever, and it understands the framework and it will then know like, okay, this is your own code. And I know that, okay, this is a JDBC call. And then it will extract the JDBC query or the SQL query behind that. And then it can tell you, okay, this is how long the SQL query took. And this is how long it took to call this service. And this is how long it took to render the front end. And this is the entire call time. So stuff like that is very easy to extract. Also where errors happen, or what is the error rate, or if you have some slow requests, and then you can easily filter down on those slow requests. So the tracing and APM really comes more into this like a system level and cross-cutting concern into play, whereas the logs are more on the component level to see explicitly like, okay, here log something on debug maybe, and here do a warn if this happens. So that's the way I would see it. And what makes most sense for your scenario, maybe a combination, but it will depend a bit on what you're trying to get.
Okay, thank you. Thomas asked before that regarding standard output and STD out and application data. You mean the example in your GitHub repository you linked at the beginning in the chat, or there you can take a look at the examples regarding. Yes. Okay.
So for Java, I'm using the console. So basically, the console is the output that will go to standard out, and that's what we can collect then afterwards. And you could either encode that as JSON, and then you will need to decode JSON in JSON, or you would need to parse that console message. That's how you would get to that, or that's how it gets from the Java application to the Docker or Kubernetes log, and then into the stack.
Okay. Maurice has also an interesting question. What would you recommend for a startup when they need a simple and effective logging solution? Where should they start? Or what solutions should they prefer?
So I think our correct answer would be like, obviously our stack. Since we have like, it's just like open code and you can just take everything and run it yourself or use a cloud service or whatever, it won't lock you into any expensive contracts, and you can run it on-premise or in a cloud service or wherever you want. So that would be our generic answer. But I'm probably not the best person to like compare all the logging frameworks or logging solutions out there.
Okay, thank you. I'm a little bit disappointed. I thought you come with the consultant-wise, it depends at the beginning. Are there any other questions? Because when it comes to logging, I'm not that good with logging. I'm just curious what in your experience with logging and things like that, what were the biggest mistakes you encountered with logging so far, and how would you have prevented them actually?
I mean, I'm not sure about prevented. Like, I think there are different levels of where you can make your life complicated. Is maybe if you're very new to development, you use system println rather than a logging library, and at some point you figure out you want to have like a logging facade and then a logging backend, and then in the logging backend you can influence how to do stuff. The other thing is for people who have been doing this for a bit longer, they often use this parsing, and then they have maybe different log patterns for every application they run, and they have a lot of applications, and then they write regular expressions to parse like a lot of different applications, and that can get kind of painful. So that's what I would try to avoid. But there are like different pain points in depending on where you're from, or like at what level you start, basically. And then the obvious problems are like maybe you have like some logging storm where you misconfigure something and then you kill your logging system because you just log something in a loop, or maybe have the wrong logging level or whatever. Like there are plenty of things that can go wrong if you don't keep an eye on them.
Okay. Yeah, cool. One last question from my side. If there are not any others in the chat, then I would afterwards close this session. So the question is, so you said that structured logging is actually the thing you would recommend for a normal Java application, or regularly for logging compared to parsing. I think that's quite interesting for, I think, a lot of people, is how you would migrate like from Java to the structured logic. Because in my opinion, if I understand that correctly, the only thing I have to do is take an additional log appender, which uses a JSON file, and then configure Kibana, also beats and Kibana correctly, if I'm wrong. And then that's actually it. So that's not like a big hurdle or refactoring or anything. I do not have to touch my log messages or anything like that. It's actually good to go with what I have actually.
Yes, I mean I think that's the general power or the idea. Once you have a proper logging solution in your application, then it's just like in a single place you change the configuration of how you want to output this, if it goes to console or a file or a JSON file, or you send it directly to some other system or whatever. It should only require a change in that one central place, which is maybe XML or maybe code-based or whatever. But it should really only change anything in one single place. So once you have that, your life will be, or it will be much simpler to make such changes anyway, yes.
Okay, cool. Thank you. Well, I thank you for this session. It was really quite interesting and a cool insight into logging from my perspective. I hope the chat also liked it. Thank you very much. I hope you enjoy the rest of Acento Dev. And thank you very much for your time.
Have a good day, everybody. See you around. I'll be at the various channels at the conference. Bye.
Bye.